Hey there, Neon friends! Last year I made a video about a shipment full of equipment that I bought to build my own neon processing manifold and vacuum system. What was still missing was the Bombarder, and some months later I got the chance to buy one. The Bombarder is the high voltage, high power transformer necessary to burn out the impurities and contaminants of the tube during processing and also to activate the electrodes. I haven't found the time to set it all up, but I will at least show you this interesting piece of equipment today. My friend David from the Neon Preservation channel kindly allowed me to use these photos. You see his processing table in the making, and there is a big heavy transformer on the left and what is called a sliding choke over here. You need a way to control the amount of power that the Bombarder sends through the tube. And you can imagine the choke as a kind of high power adjustable resistor, although it works inductive and not resistive. Now for the most basic bombarding system you need AC power, then a large contactor or switch, then some device to control the amount of power, for example a sliding choke with the core that can slide in and out, and then the bombarding transformer. And the neon tube connects here, like that. Now the thing that I bought has about the size of a washing machine and is a bit more complex, not because I wanted or needed that, but it was the only one that I could find. Germany has no market for used neon equipment and I had to call through shops to find this thing. When bombarding, you need to have specific currents flowing through the neon tube at specific steps, and the tube will have very unstable electrical properties in the process. So you have to keep your hand on the choke and control the amp meter and keep regulating the current with your hand. And this Bombarder does that automatically. It has 3 presets you can dial in here, and then you can just jump to each preset with these buttons. And the electronics will keep the tube current on that exact value by regulating the power to the transformer with a thyristor power controller. That's like a high power dimmer for the bombarding transformer. In the back of the cabinet we have the power transformer that connects to the tube. And here's the label saying that it can do either 10 kV at 1.5 amp or 20 kV at 0.75 amp. This output is lethal. If you touch the output of a regular neon transformer, let's say 9 kV 30 milliamp, your chances of surviving are pretty high. Your chances are much lower for surviving when you touch the output of this thing, so you have to be absolutely focused when bombarding, and they recommend a safety door with a switch or at least a foot switch to be used. And this is the main electrical cabinet. We're looking at 1992 technology here. This is the mechanical main switch, then special fuses to protect the thyristor controller. This controller was made by ABB, and a custom circuit board that does the constant current regulation. On this rail we have some contactors that I'll explain in a bit, and on the bottom there's terminal strips and a control voltage transformer. This is the power wiring schematic. We have the line voltage coming in here. You see that only 2 phases of the 3-phase supply are used. Going through the main switch and main breaker, then the main contactor, the special fuses protecting the thyristor controller. Also interesting to see that one phase just passes through here and just one is controlled by the thyristors. Then up here we have a series choke, so this connection is interrupted. Series choke limiting the inrush current from the grid and limiting current spikes going through the tubing. Another smaller choke coil, and then these 2 contactors switch the transformer primaries to either the 10 kV or 20 kV mode. The transformer output, high voltage output, is here. Here's another circuit breaker protecting this voltmeter, current sensor down here, and I must admit I'm not sure what these resistor and capacitor here are doing. And then down here there's another circuit breaker protecting this control voltage transformer that makes 220 volt output for all the contactors. And this is the contactor control circuit. You see that I added my own comments when I deciphered that page, and it's not as difficult as it looks. So this first lamp just shows the presence of the control voltage, and then this first current path here is a auxiliary contactor for main power on. So if you turn the switch, key switch, the stop switch is not pushed, the emergency off is not pushed, and there is no error, then this auxiliary contactor pulls in, and that immediately turns power through to this main contactor K1M. As long as the K1M was off, current was going through here and lighting up these lamps that say high voltage off. So as soon as this pulls in, high voltage off lamps go out. Then this contactor says no error, so the conditions are a door switch or a foot switch or whatever is closed. Then the breaker for the voltmeter is okay, the temperature switch in the choke is okay, the temperature switch in the transformer is okay, and both the special fuses are okay. Then this contactor pulls in and says we have no error. This lamp gives the status of the door or the foot switch, and this is the error lamp. So as soon as this contactor no error turns on, this contact opens and the error lamp goes off. When we have either 10 kV or 20 kV mode selected and the auxiliary contactor is on and we have no error and the main power contactor is on, then this contactor gives the enable signal to the thyristor controller. Then K4 is the contactor that selects between the 10 and 20 kV mode, and then here these contactors switch the transformer primaries to either 10 or 20 kV mode, and they are interlocked by these contacts of K4, so it's either this one or that one. What I'm still looking for is the schematics for this current control stuff. But even in case something here breaks one day and I cannot fix it, then as long as I have the big transformer in the back, I could basically downgrade the whole unit to a manual control with either a sliding choke or a manually controlled thyristor unit. I hope you enjoyed looking into this unusual piece of electrical equipment, and I will keep you updated once I am ready to turn it on. Until then, take care and stay tuned.